Solar energy has been available commercially for over 40 years, evolving significantly during that time. Efficiency has steadily increased while costs have fallen dramatically. Photovoltaic solar prices alone have declined by 90% over the last 10 years. Incentives, including the federal investment tax credit covering 30% of a residential installation, have further reduced financial obstacles. Yet, a full rooftop system in the United States still averages $21,800, a figure out of reach for most homeowners. The panels themselves are only part of the expense. Adding a licensed solar contractor, a structural engineer, city permits, and an interconnection agreement with the local utility can easily double the installation cost. Ownership is also a factor. Renters typically lack permission or incentive to install a system they cannot take with them. These challenges explain why only about 7% of American homes have solar panels, leaving 93% dependent on utility corporations, which continue raising prices while reporting record profits. New technologies are now breaking these barriers. For a few $100s, households can obtain a solar array roughly 80% cheaper than conventional systems. These plug-in solar systems require no technical expertise or professional installers. They can connect to any standard wall socket and be mounted on a balcony, garden fence, or backyard frame. This development is one of the most significant in residential energy in recent years. The modern plug-in solar concept began in Germany in the late 1970s during the global oil crisis. German electricity prices have long been among the highest worldwide. By 2025, the average residential rate approached 40 cents per kilowatt hour, about 2.5 times the American average of 17 cents. Following the European energy price surge of 2022, German energy costs rose more than 40% in just 2 years. In response, hundreds of thousands of citizens purchased inexpensive solar kits from hardware stores, mounting them on balconies and plugging them into outdoor outlets. This movement, known as the Balcony Power Plant or Balkenkraftwerk, became so widespread that the German government rewrote energy policies to protect tenants' rights to plug in solar panels. The legal framework, called Solar Packet, classifies these systems as consumer appliances, equivalent to refrigerators or kettles, ensuring tenants can install them on apartment balconies. By the start of 2025, over 1,150,000 systems were operational nationwide. Understanding plug-in solar requires knowing how it functions and how it differs from traditional arrays. The PV panel itself operates conventionally. Sunlight photons strike a silicon wafer, dislodging electrons between positive and negative layers, generating direct current electricity. The difference comes in converting this power for household use. Modern microinverters attach directly to the panel, performing two key roles. First, they convert the variable direct current into alternating current at 60 Hz, matching the American grid and standard home wiring. Second, they maintain the output voltage 1 or 2 volts above the local grid voltage of 120 volts, enabling plug-in solar to function safely and efficiently. Electricity flows from higher to lower pressure by sitting just above the grid voltage. The microinverter feeds power directly into household wiring, acting as a fast-track path. Any appliance on the same circuit uses the solar electricity first, before drawing from the utility. If a refrigerator consumes 200 watts, and the panels generate 200 watts, the meter at the house does not move. This is the system's intended design, covering the base load of daily energy use. Even when a house seems empty, it draws between 200 and 400 watts in the background to keep the refrigerator compressor cycling, the wireless router running, and standby loads on TVs and game consoles powered. There is no large battery bank to run off-grid, avoiding expensive installations. The system simply offsets the home's standing load and reduces dependence on costly utility electricity. Concerns around plug-in solar have been widely discussed. The main issue cited by regulators is grid islanding. This occurs if the utility loses power during a storm while a residential system continues feeding electricity, potentially endangering utility workers. Certified microinverters address this with anti-islanding protection. They require the utility's reference signal to operate and shut down in under 20 milliseconds if the signal disappears. Another concern is branch circuit overcurrent. A standard 15 amp household circuit safely carries 15 amps, but if the utility supplies 15 amps and a microinverter injects an additional 5 amps, downstream wiring could carry 20 amps without tripping the breaker, since the breaker only measures current from the utility side. European regulators solve this by limiting plug-in systems to 800 watts output, roughly 3.5 amps, keeping loads within the safety tolerance of household copper wiring. These are the two most cited objections, both mitigated with proper regulation. The benefits are significant. In Oakland, California, a pilot program called Bright Saver distributed plug-in systems to renters and retirees, tracking actual savings. Participants reported monthly reductions of $25 to $30, translating to $300 to $360 annually, roughly a 2-year payback period. BrightSavers modeling for a 4-panel kit estimates around $500 saved per year for a typical 4-person household. One early adopter in California saw purchased utility energy drop by 22% within the first week of operation. Plug-in systems do not produce fully off-grid homes, but they offer advantages over traditional rooftop arrays. Large rooftop systems generating excess power must sell back to the grid, often at heavily reduced rates. In California, utilities sell electricity at about 40 cents per kilowatt hour, but credit exported solar at only 5 to 10 cents. The homeowner effectively provides cheap electricity for resale at 4 to 8 times the price. A plug-in system avoids surplus. Every kilowatt hour it produces replaces a kilowatt hour that would have been purchased at full retail. Legal installation is the next challenge. In the United States, plug-in solar lagged behind Germany for structural reasons. Without a federal safety standard, each state regulator had to decide independently whether consumers could safely backfeed electricity into household wiring through a standard outlet. Most states initially prohibited plug-in solar, although some have acted to formally include the technology in legislation. In March of 2025, Utah became the first state to create a legal category for portable solar devices up to 1,200 watts, exempting them from utility interconnection agreements and preventing homeowners associations from banning them. In January 2026, UL Solutions launched UL 3700, the first dedicated American safety and certification standard for fully assembled plug-in solar systems, closing the regulatory gap utilities had used to block compliance. Afterward, several other states also moved to embrace plug-in solar. Maine signed its law in April of 2026, capped at 1,200 watts and effective in July. Virginia followed with the same cap, effective on the 1st of January 2027. Colorado set the highest cap in the country at 1,920 watts. 5 days later, on the 12th of May, Maryland Governor Wes Moore signed House Bill 1532, the Utility Relief Act. At the time of recording, 5 states have dedicated plug-in solar legislation: Utah, Maine, Virginia, Colorado, and Maryland. California's Senate Bill 868, the Plug into the Sun Act, is progressing through the legislature with similar measures. States that have not acted remain in regulatory uncertainty. The hardware itself is legal to own and sell, particularly kits certified to UL 3700. What is missing is protection from utility interconnection rules, HOA aesthetic restrictions, and landlord objections. In states without formal agreements, plugging panels into a wall outlet may violate local codes, causing metering issues or conflicts with homeowners associations. Several options currently lead the American market. The Solix Solar Bank 2 includes a built-in lithium iron phosphate battery rated at 1.66 kilowatt hours, expandable with stackable modules, a current transformer clamp, and a 10-year inverter warranty. Kits range from $1,200 to $1,600, though each panel weighs around 48 pounds, complicating balcony rail mounting. The EcoFlow Stream system uses a detachable, modular battery for portable power, costing $1,200 to $1,500 with a 5-year inverter warranty. The Zener Hyper 2000 is the most flexible, supporting up to 1,800 watts across 4 maximum PowerPoint tracking channels, integrates with open-source Home Assistant platforms, and offers time-of-use tariff optimization priced between $1,300 to $1,800 with panels sourced separately. Setup is similar for all systems. Panels mount to south-facing or southwest-facing balconies, ground frames, or fences using wind-rated brackets. MC4 cables connect panels to the inverter or battery hub. An outdoor-rated AC cord plugs into a grounded exterior outlet with a ground fault circuit interrupter. The system syncs with the household grid frequency in about 5 minutes and begins generating electricity. Before buying, verify 3 points. The kit must carry UL 3700 certification, not the older UL 741. Confirm current state legislation. Renters should review their lease and consult landlords, ideally with relevant state law, especially in Utah or Colorado. Plug-in solar will not replace a full electric bill. It cannot run central air in a Texas August or charge an electric vehicle overnight. Proven evidence from multi-state pilots and over 1 million installations in Germany shows it can reduce bills by $25 to $30 per month for the next 25 years without a contractor visit or utility approval, bringing households closer to energy independence and reducing reliance on overpriced utilities. Please leave your thoughts about this content in the comments below. Thanks for watching. See you in the next one.